Good morning. Today we're going to cover 3.3 composition of functions with tables and graphs. Yesterday we did composition of functions using equations and substituting in values. So when we evaluate a composition function using tables, we're going to follow the same process we did yesterday. We start with the inside function first, and then use that value to evaluate the outside function. So if we look at example 1, it says use these tables to evaluate the functions. Starting with 1a. First thing I'm going to look at is the inside function. I want g of 2. So I'm going to come over to the g equation, go to where x is 2, and my answer is the y value. So where I have g of 2, that equals 5. So I'm going to substitute in the 5 for the g of 2. So this becomes f of 5. Now I go to the f table, find my x value of 5, and the y value at that point is my answer. So f of 5 equals 9, so therefore this answer is 9. So let me clear what's up here, and we will go on to B. Same process. So f of 3. So I'm going to start over here on the f table, find 3. That value is 4. So this becomes g of 4. Now I evaluate my g function. G of 4 is 7. So the answer is 7. Okay, on C, I'm starting off with g of 1. So g of 1 is 3. So this becomes f of 3. Now I go to my f table, find 3, and that answer is 4. Last one. Start with the inside function first. So f of 4. So come to the f table, find 4. F of 4 is 1. So this becomes g of 1. Now I go to my g table, find 1, and that value is 3. And there's your answer. We are going to do the same process, but with tables or with graphs as well. So when we evaluate composition of functions using graphs, we will use a similar procedure for evaluating graphs that we've used for evaluating tables. We will read the input and output values from the x and the y axis on the graphs. First step, you're going to locate the x value of the inside function. You are then going to find its corresponding y value. You will write that down. You will then use that y value as your new x value for the last function, and then find the y value for there. So again, we're going to step through some examples, and it should become clear. So if I look at this first one, I first start at g of negative 2. So I come over to my g, find negative 2 on the x-axis. That is this point. I then write down its y value. So this now becomes f of -3. So now we evaluate the second function, f of -3. So I come and I find -3 on the x-axis, find where it intersects the graph, and my y value at that point is the answer, which is 1. Let's look at the next equation. F of 0 is where I start, so I go to 0 on the x-axis, which is right here. The y value is right there. So that becomes g of -2. So now I come over to the other graph, find -2 on the x-axis. The y value at that point is my answer. So this equals -3. Let me take a second and clear off the graphs. Let's look at C. So again, I'm starting with the inside function first, g of 1. Go to the 1 on the x-axis, locate the point, find its y value. So that is 2. So this becomes f of 2. So I go to my f function, find 2 on the x-axis, locate the point on the line. That y value is 3. And finally, D starts at f of 4. So go to 4 on the x-axis, locate the point, read the y value, so that is 5. So this becomes g of 5. Go to my g equation, find 5, locate the point, write down its y value, which is -2. So the last thing I want to go over is something that we did yesterday, which is adding, subtracting, and multiplying functions. But I want to do it with a specific point in mind. Yesterday we just did it as x. What happens if I put a number in? So what I want you to do is turn over your note sheet, and we will go ahead and write a couple notes on the back. So we will call this example 3. So for example 3, we are going to use these functions. F of x will equal 2x squared plus 3. And g of x will equal x minus 7. So for A, I want to do f plus g of 3. So remember from yesterday, the first thing we do is when we see that, we rewrite it as f of 3 plus g of 3. So I am going to just come over to the side. And we are going to evaluate these two functions. So first, I'm going to evaluate f of 3. So I'm going to take 3 and plug it into f. That is 2 times 3 squared plus 3. We're going to put that in our calculator, and we get an answer of 21. So we are going to replace f of 3 with 21. I'm going to also evaluate g of 3. So plugging 3 into g. 3 minus 7 That is negative 4. So we're going to replace g of negative 3 with negative 4. And now we just bring down the signs. So 21 plus negative 4 is 17. Okay, let's try another one. So if I have f minus g of negative 2. So again, first thing I'm going to do is rewrite it as f of negative 2 minus g of negative 2. And I'm going to come over to the side. First things first, f of negative 2. And make sure when you do this, in your calculator, you are putting the negative 2 in parentheses. If you don't, you're going to get the wrong answer. So when you do, you should get 11. So I'm going to replace this with an 11. G of negative 2, same thing. Come over to the side, we're evaluating g. So negative 2 minus 7. That is negative 9. So this becomes a negative 9. Now we bring down our signs. 11 minus negative 9, plug that in your calculator or know that minus a negative turns into plus a positive, and you will get 20. Okay, the last one I want to do is a multiplication one. So number C, or letter C, we are going to do f times g of 4. So first step, rewrite it, f of 4 times g of 4. Come over to the side, we're going to figure out what is f of 4. F of 4 is 2 times 4 squared plus 3, which is 35. And now we're going to figure out g of 4. So that's going to be 4 minus 7, which is negative 3. And because it's multiplication and I have parentheses, I don't need to bring down my sign, but if you want to, you can. 35 times negative 3 is negative 105. So today's worksheet is going to have some of the new stuff from tables and graphs, and then some review from yesterday. So we're going to do some addition and subtraction with evaluating functions at a number just like this. And then we're going to do some composition of functions both at a specific point and with the function itself using the equations, so not using graphs. Let me know if you have any questions.